Okay, Aubrey, we are right in the middle of section 5.1 for stats. We just finished a chapter. I'm going to have you guys really quick cross off the formula that they have up at the top here, because I'm not going to worry about formula until we start section 5.2. Okay? This is the backside. This is the top of the second page of 5.1.
Oh, we're on 5.1 still.
Yep, 5.1. So cross off the formula. We'll wait, and they have a different formula that we use, not that one. But we'll wait to introduce that to section 5.2, because let's just talk about probability distributions first. Okay, here we go. The heat? I don't know.
No.
No, we don't want the heat? I want the heat. Billy, go warmer, warmer, warmer. Back there on the thermostat, would you?
There's going to be a sauna next door.
Yeah, it might be. We'll see. It'll be fine.
I was cold in Newton.
They're probably going to freeze to death like next period, or next door. All right, here we go. This is something that you will experience quite a bit as you're filling out these probability tables, okay? We will eventually get to the point where we have a formula for calculating probabilities when the probabilities are disgusting, okay? So there's a formula for filling out this table. We're not going to do that in this section, maybe in the next section, okay? And that's what the formula that I just had you cross off was, okay? Now, circle and star and box and do all of the things for the notation for 0 plus. This is something that you will see quite a handful of times. And here's what 0 plus means, okay? If you have the probability when you type it into the formula and you do all the things and you get like 0.00000000001, right? Like that rounds to 0 basically, right? But we never say that the probability is 0, because that means it's impossible. This is not impossible. It's not going to happen very often, but this is not impossible that it's going to happen, right? Okay, so what we do instead is we say 0 plus, which means it's just slightly above 0, but it's not completely no chance of happening. Does that make sense? That's what 0 plus means. So if when you're filling these out and if you end up doing calculations that end up 0.00000, like a bunch of zeros and then some numbers, right? Just put 0 plus in its place, okay? I would say if there's more than like 5 zeros, you could do 0 plus, probably. Okay. 4 or 5 zeros. More than that, yeah. Okay, good? All right, there you go. Okay, example 2, job interview mistakes. Okay, you typically won't see a probability table that looks like this because why? Well, that's one thing that we have to do, right? But what about over here? These are categories, okay? And you can do a probability table with categories, but going forward, doing calculations with that, we usually won't have categories. It's fine, but we usually typically won't have categories because we had things before that was like not a random variable. Do you remember that? Classifying the data into discrete, continuous, and then not a random variable. That's the stuff that you guys missed on Friday. But those are categories. Here we go. It says, does this table describe a probability distribution? Somebody already said it. We have a problem. What's the problem? It doesn't equal 1. All of these probabilities of those things happening have to add up to be 100%. And this is like 157%. Not good. Not equal to 100%. It's above 100%, which means whatever, okay? Now, let's just look at what this is asking. This is talking about mistakes that job applicants make in their job interviews. Like 50% of the mistakes that are made have to do with inappropriate attire. Being late, you better never be late for an interview. None of you. You better know better than that. Lack of eye contact. I think this one should be higher. Because lack of eye contact, a lot of you younger people who have never interviewed before, like do that like without even knowing that you don't like. I do that sometimes when I'm talking to people, like I don't look them in the eye, you know, like whatever, like carrying on a conversation just because I have like so many other things in my mind, right? Okay. Lack of eye contact is a big thing. That's probably more prevalent than people think. Checking your phone or texting. Honestly, really, like, do people actually do that? Like, check your phone or text during an interview?
I feel like that should be instant disqualification.
No kidding.
So I feel like it should be higher
No
than the
kidding.
inappropriate attire.
What? I don't know. So these people are idiots right here. Like, I get lack of eye contact. Okay, whatever. But the other ones that you have control over, come on. Step it up, folks. All right, here we go. Probability distribution. Here we go. We talked about this one before when we're talking about heads and tails. What?
We should go into a car accident. That would be a good reason to be late.
That's true. That's true. Yeah, unless you had an excuse. Yeah. In which case, I would, like, maybe call them and say, I don't know. Whatever. That's another story. All right. So we've looked at this probability table before, yeah? Number of heads when tossing 2 coins. Okay, tossing 2 coins, you could get a heads. You could get a heads tails. You could get a tails heads or a tails tails. That's how they came up with this stuff. They're talking about the number of heads that you get. So 0 heads would be this one, right? And that is happening 1/4 of the time, right? 1 head would be these 2 combinations. That's happening half of the time, 2 out of 4, right? And then 2 heads would be heads, and that's happening 1/4 of the time. That's this probability table. Got it? Okay? All right. Now, how do I find the mean, the variance, and the standard deviation when I have a table that looks like this?
That's a great question. Probably put them in the dumb.
Yeah, you put them in the dumb equations over there. Okay, so here's the deal. Do you remember before when we talked about weighted average? Like, this was your score on a test, right? And this was how much that was weighted. And this was your score for homework, and this is how much it was weighted. And this was your score for quizzes, and this is how much it is weighted, right? What did you do for those? Multiply them, add them together, and divide by 1, or 100%, right? That's exactly what we're going to do here, okay? So 0 times 0.25 is 0. 1 times 0.5 is 0.5. 2 times 0.25 is 0.5. And if I add those together, I get 1. And then if I divide by 100%, I still get 1. Okay? Now, listen to what I just found. I found the average number of heads that should show up if I toss 2 coins. On average, if I toss 2 coins, I should get 1 head. On average. Does that make any sense at all?
Yes.
That makes perfect sense, right? Okay? And that's how you calculate it. With this table, you multiply and then you add them up and you divide by 100% or just 1, right? So you really don't have to divide by anything. But that checks out, right? That should make sense, okay? That is what they're saying here, okay? Everybody look at the formula. X. What is X? These guys right here are your X's. Okay, you take it times P of X, which is this column right here. These are my P of X's. I take that times that, and what does this little guy mean? The sum. I add them all together, right? I take all the X's times their respective P of X, right, in the column, times, and then I add them all up, and that is how you find the mean, which is mu, right? Mu. Sometimes we also called it X bar. Do you remember the difference between the two? This is the mean for a sample. This is the mean for a population, okay? Now, we are talking about the population of coins. If I flip 2 coins, no matter what, the population of coins should either be 0 heads, 1 head, or 2 heads, right? So that's why we're doing population. That's why we do mu, okay? All right, here we go. Variance. We have 2 formulas for variance. We're going to use the bottom one. Circle the bottom one, cross off the top. Okay, we're going to use the bottom one. What? I don't know. I think it's easier. Actually, you know what? I think they use the top one. It doesn't matter. You can use whichever one you want. Let's do this one. This is the formula for variance. Actually, variance is right here. This is the formula for variance. They're using the top one. Sorry. You can use whichever one you want. I don't care. Okay. All right, here we go. They want us to first find the mean, which is using this table, or this column. Then they want us to find the variance, and they want us to find the standard deviation. So we've got all 3 going on here. Okay, mean. We found the mean already. X times P of X is 0 times 0.25, which is 0. And 1 times 0.5, which is 0.5. And 2 times 0.25, which is 0.5. And if I add all those together, I get 1, and that is my mean. Okay, the sum of all the x's times the P of x's. Got it? Okay, now we're going to fill in this table. And I'm going to take the sum of these, but I've got to do each one individually. So the first thing I'm going to do is I'm going to take x minus mu. Okay, what does x minus mu look like for this first column?
0 minus 0.
0 is my x. So I have 0 minus, no,
1.
1. 1 is mu, right? Okay, and I'm going to square that because that's what the formula says, times p of x, which is
0. Right? No.
Nope, what's p of x?
0.25.
0.25. Okay, all right. What is 0 minus 1? Negative 1 squared is 1, and 1 times 0.25 is
0.25.
0.25. Got it? Okay, the second time I set this up, what's my next x? 1 minus, average is 1 squared times, what's p of x?
0.5.
0.5, right? I'm just going down the column. 1 minus 1 is 0. 0 squared is 0. 0 times 0.5 is 0. Okay?
2 minus 1 squared.
All right. Yep. The next one. My x is 2 minus the blah, 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 the average, which is 1 squared, times 0.25. All right. 2 minus 1 is 1. 1 squared is 1 times 0.25 is 0.25. And if I
Add
take
0.5.
the sum of those,
0.5.
I add those all together, 0.5. Got it? And that is this guy, which is sigma squared, which is the variance. So the variance is 0.5.
What's
Now,
sigma then?
how do you find the standard deviation?
Square it.
Equals the square root of the variance. All right? That's why if the variance is sigma squared and I take the square root, standard deviation is sigma. Yeah? That was a lot of stuff going on. Billy, are you watching?
So what is our standard deviation?
So what was your variance?
0.5 squared.
The square root of 0.5 was the square root of 0.5.
0.25? No.
No. It's like 0.707. Check that. I think that's what it is. Standard deviation. 0.707. I'm so smart.
How'd you figure that out?
Because it's the square root of 2 over 2.
Huh?
It's 0.707.
Didn't understand that.
It's trig stuff.
Okay.
The square root of 2 over 2 is the same thing as the square root of 2 over 2 is the same thing as the square root of 0.5. No, it's not. I don't know. It's a number that shows up in trig stuff a lot. 0.707. So that's your standard deviation. Whatever. I don't know how I know that off the top of my head. 0.707. Okay? That's my standard deviation. Got it? Okay. Now, questions about that? You just follow the formula and all the things, right? Okay? Follow the, when you do your standard deviations and stuff, I would come back to this table and make reference to this guy. That's what I would do if I were you, because you're going to have to find mean and standard deviation and all the things. Okay? All right. Let's do just a couple more things, and then we'll stop before we get to part 2. Okay? Because that is expected value. That is like gambling stuff, and we'll stop there. Okay? Now, you guys have already done this, though, before, right? If I say the average of a test is an 80 with a standard deviation of 5, whoop, 80 lives in the middle. What is considered to be a significantly high test score?
90.
Why 90? Two standard deviations, right? You add the 5 and then you add the 5 again, so anybody that scores above 90 is significantly high.
Below 70.
Okay, or high, why did I put T? I don't know. 1, 2, if you subtract 5 again, anybody below 70 has a significantly low score, right? Okay, significantly high, significantly low. You know that you add 2, right? Add 2, subtract 2, standard deviations. That's what this thing says here. Values that are not significant. Sorry, if you scored between a 70 and 90, you are not a special person. True? You're not, you're average, basically, right? If you score a 90 or above, or below a 70, you're like significantly bad here, right? You're significantly good if you're here, right? Whatever. You're of significance if you're in the two tails. Got it? Okay, identify significant rules with they call this the range rule of thumb because you're looking at the range of values. All right. In example 3, we found, what?
Didn't we learn this already?
Yeah, we talked about this before. The 2. Yeah, that's called the range rule of thumb. The mean number of heads. I'm just going to write this information down. We got a mean number of heads was 1.0, right? The average number of heads that you should get if you flip 2 coins is 1, right? That's what we got. We also got a standard deviation of 0.7 or 0.707, whatever. Use those results and the range rule of thumb to determine whether 2 heads is a significantly high number of heads. Okay, let's see if this makes sense. 1 is the average number of heads that you get when you flip 2 coins, yeah? If I add the standard deviation twice, that is like adding 0.7 and adding another 0.7. That gives you 2.4. Okay, if I subtract 0.7 and I subtract 0.7, minus 0.7, minus 0.7, that would be like negative 0.4. Okay, let's talk about what this means. Okay, because you will end up getting results that look like this and you're going to be like, what the heck do I do here, right? This is saying that when I toss 2 coins, if I get more than 2.4 heads, it's considered to be significant. How do you get more than 2.4 heads when you're only tossing 2 coins? There are no values that are significant, right? You wouldn't be like, oh my gosh, wow, if I got 0 heads, right? You wouldn't be like, oh my gosh, wow, if you got 1 head, and you wouldn't be like, oh my gosh, wow, if you got 2 heads, right? Because you're only tossing 2 coins, okay? If we were tossing 20 coins, it might be significant if 17 of them turn up heads, right? But if we're only tossing 2 coins, it's not significant to get 1, it's not significant to get 2, and it's not significant to get 0 because the range of values that's not significant goes from negative 0.4 to positive 2.4, which aren't even values that I could get, right? I can't even get those values. Does that make sense though? The only thing that I could get is 0 heads, 1 head, or 2 heads, and because they live in that insignificant region, then it's not significant, right? So use those results and the range rule of thumb to determine whether 2 heads is a significant high number of heads. Is 2 heads a significant high number of heads?
No.
No. 2 is not significant. Does that make sense? You can sometimes get negative values and values that don't even make sense, right? 2.4 doesn't even make sense. Negative 0.4 doesn't even make sense. That is legit. Sometimes that will happen. Okay?
But
Good?
we're like ignoring the.
These 2 numbers, even though they're like impossible to happen, those tell me what's considered significantly high, significantly low. So, because 2 is the highest number of heads I could get and it still lives in the middle, then 2 is not considered as, you wouldn't say, wow, I can't believe I got 2 heads when I flipped 2 coins. You'd be like, so that happens sometimes, right? You wouldn't be like, oh my gosh, I can't believe I got no heads when I flipped 2 coins, because that happens sometimes, right? What?
Or 2.4. If I got 3 heads.
If you got 3 heads out of 2 tosses, that would be wow, right? Like, because you can't do that. Okay, good? Beautiful. All right, now. Okay, last example.
What did we learn in calc with the whole, like, those?
What?
There definitely was.
But did we find the slope of that
2004,
in
that was a good year.
calc? Or we used those to find
Rectangles.
something.
Uh, what? Yeah, we did the rectangle method stuff. Yeah.
Determining
That was for any curve, though, not just a bell
Yeah,
curve.
yeah, but what is it called? What is it called?
antiderivative.
need that marker. Young and
Yeah, they were antiderivatives. Yeah. Antiderivatives is area. Yeah. Yeah, I know. I will take you. What do you have 5th period? Come join us. What do you have 5th period? Oh, quit accounting and come join us. Okay. All right, here we go. Last question, and then we'll stop. Okay, you ready? If I flip a coin 460 times, if I flip a coin 460 times, what's the average number of heads I should get? 230, right? Half of them should show up to be heads. That's why they put 230 in the middle of this bell curve. Okay? Now, I'm doing this. They are saying they ran this formula. Okay? There is a formula for finding probability. You don't have to write this down, but here's what it is, just so you know I'm not full of crap. P of x is equal to NCR times P to the R times Q to the N minus R. This is how you find P of x. on a table. You don't have to write this down. I'm just giving it to you so you know I'm not full of crap. Okay? So what they did was they said if I'm tossing a coin 460 times, 460 goes in for N. Okay? R is they want to know what the chances of getting 252 of them to be showing up as heads. Okay? Is 252 wins in those 460 games considered significantly high? They plopped that stuff into this formula. R is also 252. Do you know what N minus R would be?
460 minus 252.
460 minus 252, whatever that is. 208, right? P and Q is the probability of getting a heads versus the probability of not getting a heads. So that would be 0.5 and 0.5, right? And they plop that into this formula. If you try to do it in your calculator, it might have like an overflow error just because 460 is a huge N, okay? So we could do that with a calculator, but you could try it if you want to, okay? It might give you an overflow error. It might not. But if you type that in, you should get this number right here, which is 0.0224. And that is telling you the chances of getting 252 turnip heads out of 460. I'll say that again. The chances of getting 252 to show up heads, right? Average is 230. The chances of getting a 252 and 208 split is 0.0224, which is 2.24%. Is 252 considered a significantly high number of heads? Why?
Because it's less than 5%.
This number is less than 5%. So less than 5% of the time, I am getting 252 heads, which means 252 is a significantly high number of heads. Does that make sense?
How do they do it if it doesn't work on the calculator?
They do it with a computer. Your calculator is just like I don't know. There's some calculations that you have to do with the calculator. Yeah. Or with a computer, I mean. Yeah.
Reese, what was that one term that you used to gaslight us with?
Cuspid. It is true. I laminated it and I sent it to all the seniors. I
In
did.
their packet? Or not
In their card that they got for graduation. I laminated it.
Have they learned about the cuspid?
No, we haven't talked about cuspids yet.
I forgot even what they are.
Eli.
Or something.
It's one of these.
Oh,
It's the tippy tip.
Because you can't find the derivative here.
Yeah, it's the tippy
Yeah.
tip.
What day of April did we take
Alright.
our ACT at the school?
Okay? So, two ways of determining significance. If it's beyond 2 standard deviations one way or the other, that's significant. It is significant if it has a less than 5% chance of happening. So, 2 different ways of determining significant. Yeah? Got it? Okay, we will do expected value tomorrow. You should be able to do, woo, like everything except number 3.
What? You're joking.
I am not joking.
I like really don't
Whoop.
appreciate that.
None of them. What?
Okay, you should be able to do all of them except number 3.
Oh.
Okay?
There's 2 number 3.
I'm not doing that.
Oh yeah, 1, 2, 3, and then 1, 2 on the backside. Okay? This one on the backside here, number 1, be very careful finding your mean and your standard deviation and your variance and all the things, right? Just follow the table. Follow the table like I would do like an X times P of X column here. And then I would do over here another column that is
Here.
X minus mu squared times P of X column, right? That's your columns that you should do. Okay, off to the side. Got it? Okay,
What the sig-
all right, goodbye.